Hi, good morning students. This is Harsnath Sukla and today we are going to discuss lecture number 2 for class 12th. Chapter is chapter number 5, Continuity and Differentiability, and topic is discussing the exercise 5.1. So we had already in last lecture the definition of continuity. What is the definition of continuity? That means a function is said to be a continuous function if limit of the function at that point is equal to the value of the function at that particular point. So today we are going to discuss some questions based on this. So let us see. The first question is, prove that function fx, exercise 5.1, we shall discuss some questions. Prove that the function fx is equal to 5x minus 3 is continuous at x is equal to 0, at x is equal to minus 3 and at x is equal to 5. Is continuous at x is equal to 0, x is equal to minus 3 and x is equal to 5. So one by one we have to discuss this particular question. So first of all, if at any point we have to discuss the continuity of this function, so rest of them you have to do yourself. So let solution given function is fx is equal to 5x minus 3. Now limit x tends to 0. At x is equal to 0, we shall discuss at x is equal to 0. That's why limit x tends to 0. 5x minus 3 is nothing but 5 into 0 minus 3. This is minus 3. And what is the value of function, that is f0? This is also 5 into 0 minus 3 minus 3. Hence, we see limit x tends to 0, fx is nothing but f0, that is minus 3. Hence, we can say the function is continuous at x is equal to 0. Similarly, you can check at x is equal to minus 3 and whatever the points are given. Now, next question. Examine the continuity of the following function. Question number 3, D part, means fourth part. Question number 3, fourth part. In question number 3, we have to examine the continuity of the given function. So, function is fx is equal to, given function is fx equal to mod of x minus 5. We have to examine the continuity of this function at x is equal to 5. Why x is equal to 5? Because mod of x minus 5 is the function. So, see, fx is equal to mod of x minus 5. So, if we redefine it, it is minus of x minus 5 if x minus 5, that means x is less than 5. This is x minus 5 if x is greater than or equal to 5. So this is the definition of mod function. Now we find LHL and RHL. We shall discuss the continuity at x equal to 5. Then we can say this is continuous everywhere. So LHL is nothing but limit x tends to 5 minus fx. This is limit h tends to 0, h greater than 0, f of 0 minus h, f of 0 minus h. Since h is 5 minus h. Since h is greater than 0, then the 5 minus h, the quantity 5 minus h is less than 5. So for less than 5, h is less than 5, function is defined as minus of x minus 5. So we can write here limit h tends to 0 minus of 5 minus h minus of 5. See? So this becomes limit h tends to 0, 5 cancel plus h, this is 0. Similarly, we can find RHL, that means right-handed limit. We can say RHL, right-handed limit x tends to 5 plus fx, that means limit h tends to 0, f of 5 plus h, 5 plus h and h greater than 0. This is the 5 plus h is the quantity which is greater than 5. So if it is greater than 5, we have limit h tends to 0, and for greater than 5, function is defined as x minus 5. So 5 plus h minus 5, this is cancelled out, this is also 0. So you see LHL and RHL, and these values are equal to 0. Now value of the function. So f5 is nothing but mod of x minus 5. So put here 5 minus 5, this is 0. So here we see LHL is equal to RHL is equal to value of function, that is limit x tends to 5 mod of x minus 5 is equal to 0, and this is equal to value of function. Hence we can say the given function is continuous. Okay? Now next, one is question number 6. Question number 6. If fx is this much, fx is equal to 2x plus 3, x is less than or equal to 3. Now question number 6. If fx is equal to 2x plus 3, if x is less than or equal to 2, and 2x minus 3 if x is greater than 2, now here instruction for the question, find all the point of discontinuity of this function. Problem 6 to 12, we have to find all the point of discontinuity of f in each problem 6 to 12. So we need to find a point of discontinuity. So what is the point of discontinuity? Point of discontinuity is nothing but we have to discuss. We have to find the point where the function is discontinuous. So let us start. So first of all, we find LHL, limit continuity at x is equal to 2. limit x tends to 2 minus fx. This is limit x tends to 0 f of 2 minus h. F of 2 minus h. So this is limit x tends to 0, 2 minus h is greater than 0. That's why the quantity 2 minus h is what? Less than 2, and for less than 2 function is defined as 2x plus 3. That means 2 of 2 minus h plus 3. This is limit h tends to 0, 4 minus 2h plus 3. This is nothing but 7. So please note it down. This is the LHL. Similarly, we can find RHL. Now RHL is limit RHL, right-handed limit x tends to 2 plus fx. This is limit h tends to 0, f of 2 plus h, and being h greater than 0, the quantity 2 plus h is greater than 2, and for greater than 2 function is defined as 2x minus 3. So limit x tends to 0, this is 2 into 2 plus h minus 3. This is limit h tends to 0, 4 plus 2h minus 3, and this is nothing but 1 because h is 0. So 4 minus 3 is 1. So here we see LHL does not equal to RHL, limit does not exist. So we can easily say the function is discontinuous, but we find the value of function also. So value of function, that means now value of function at x is equal to 2, we have f2, and x is equal to 2, value of function is 2 into x plus 3, 2 into 2 plus 3, 2 to the 4 plus 3, this is 7. So you see LHL does not equal to RHL, okay, and does not equal to value of function. Hence function is discontinuous at x is equal to 2. So the point of discontinuity is 2. We can answer it as the point of discontinuity is 2. If we consider more definition, but it is not in your syllabus, there are some types of discontinuity also. This is left-handed discontinuity, right-handed discontinuity, because left-handed limit is equal to value of the function. That means this is continuous from left side, but right side is discontinuity. So there are so many points of discontinuity like right-handed discontinuity, left-handed discontinuity. So this is not in syllabus. That's why only we have to see the point of discontinuity. So you can say x is equal to the 2 is the point of discontinuity. Now let us see next question. Question number 7 we have fx is equal to, question number 7, let us see, fx is equal to mod of x plus 3 mod of x plus 3 if x is less than minus 3, minus 2x if minus 3 is less than x is less than 3, and 6x plus 2 if x is greater than or equal to 3. So first of all we find how many points where we discuss the continuity. So there if you see there are minus 3 and 3 is the point where we have to check the continuity of the function. So maybe at one point this is discontinuous and another point this is continuous. So where the function is discontinuous, we can say this is the point of discontinuity. So let us see at x is equal to 3. First we are going to discuss at x is equal to 3. So LHL limit x tends to 3 minus fx. This is limit h tends to 0 f of 3 minus h. So 3 minus h, as h greater than 0, being h greater than 0, the quantity 3 minus h is less than 3. So the function where the function less than 3, the function defined where the x is less than 3. So x less than 3, this is the minus 2x. So we can write here limit h tends to 0, 2 into minus of 2 into 3 minus h. This is minus 6 minus 2h plus 2h limit h tends to 0. So this is minus 6. Similarly, we can find RHL. The RHL is, if we see here, directly we can find here 3 plus h, and then function is defined as x greater than 3, 6x plus 2. So this is 6 into 3 plus h, and this is plus 2. So we can see here 6 3s are 18 plus 2. This is 20 plus 6h. This is nothing but 20. Now the value of function, that means f3, if you see f3, this is x is equal to 3, function is defined as 6 into 3 plus 2. This is also 20. So you see here LHL does not equal to RHL, hence function is discontinuous at x is equal to 3. Hence x is equal to 3 is the point of discontinuity. But it is not end of the question. You have to find the continuity at x equal to minus 3. Maybe it is also discontinuous. So there are 2 points of discontinuity. So first of all we find at x is equal to minus 3. So this is minus 3 minus LHL, and this is minus 3 minus h. So we can write here minus 3 minus h, as h is greater than 0, minus 3 minus h, this is the quantity minus greater than minus 3 minus h, then less than minus 3. Minus 3 minus h, this is the quantity less than minus 3. So less than minus 3 function is defined as minus of 2 into minus of 3 minus h, and this is nothing but 6 minus 2h. So this is 6. Okay. Similarly we can find RHL. Now RHL is nothing but x3 plus, so minus 3 plus h. This is minus 2 minus 3 plus x. This is the quantity greater than minus 3. So minus 3 plus h greater than minus 3, that means this is the function mod of minus 3 plus h plus 3. If we put h is equal to 0, then it is 3 plus 3. This is 3 plus 3, and this is nothing but 6. So you see LHL is equal to RHL. And now value of function also. So this is also value of function f minus 3. This is mod of minus 3 plus 3. This is 6. So here you see LHL is equal to RHL is equal to value of function. In second case, that is at x is equal to minus 3. Hence we can say the function is continuous at x is equal to minus 3. Hence this is not a point of discontinuity. So in this question we have only one point of discontinuity as x is equal to 3. Okay. So let us try to solve some more questions based on continuity of the function, and after that next topic is differentiability. So this is the starting of calculus. So please try to understand. This is very important topic for your board exam. So please do it. Thank you.